Subtypes allow us to indicate to GeneXus how to associate various attribute names to a single concept. In previous courses, we've analyzed and studied different cases where we define groups of subtypes to resolve conflicts or ambiguities that arise in our applications. We started with the simplest example, where we had a double reference to the same concept, but with different roles. In this case, we were asked to be able to register both the departure airport and the arrival airport of a certain flight. Later on, we studied a case of multiple indirect references, since, given a table, we had two paths to get to another one. It was the case where we had to record information about tour guides, and there were two paths to get to the country ID attribute to identify their country. In the same video, we saw a case of using subtypes to represent a specialization, where one transaction recorded the data common to people, and other transactions, specializations of the first one, recorded their particular information. In this other video, we look even more closely at a case of indirect multiple references, when we had to record the tours offered to the travel agency's clients to visit the tourist attractions of a given city. In this example, we thoroughly analyzed the problem with its different solutions, each with its advantages and disadvantages. Also, we highlight the importance of studying each particular case and determining when and where to use subtypes as necessary, and not arbitrarily. We also presented a use case of recursive subtypes, where an entity had to be self-referenced. This was the reality where we represented the information of the employees of the travel agency, where each employee could be, in turn, the manager of one or more other employees. Now let's study one last example, where we must avoid the referential relationship. Suppose we must model transactions for a reality in which we have companies and services that they can purchase, such as, for example, an emergency healthcare service. In turn, companies have employees who may also have purchased services that don't necessarily match those of the company they work for. We are interested in recording these employee services because, for example, if many employees have purchased a certain emergency healthcare service, an agreement can be sought with that service to obtain a benefit. In our reality, employees can only work in a company, but we don't want to represent them as a strong entity, but as dependent on the company. Let's look at these two proposed solutions, where one's correct and the other is not. The first solution would be to create these two transactions and the following group of subtypes. And the second solution would be to create these two transactions and the following group of subtypes. A is the correct solution, and B is not. If we look closely, in the company transaction there are two parallel levels, service and employee. This means that everything that's inferred from any of these levels will correspond to the same company. However, we do not want the employee's service to exist as a company service, since, in our reality, the employee may have purchased services different from those of the company he or she works for. In other words, when the user enters the employee services grid, we don't want to check whether the entered service exists as a record in the table corresponding to company.service. Clearly, we need to define a group of subtypes because in the same transaction, GeneXus will not allow us to repeat the same attribute name. So the question that arises is, does it make any difference whether you define it on one level or the other? The answer is no. We could define two groups of subtypes and solve the problem, but as we've already seen in previous videos, it's not good practice to define more subtypes than strictly necessary. This is because it's never exactly the same to have the subtype than having the supertype, as will be made clear with this example. Therefore, to solve the problem, it's enough to have only one group. Why then is the correct solution A and not B? Because if GeneXus allowed us to repeat the same attribute name, it would clearly find that in the table associated with the level company.employee.employeeService, with primary key, company ID, employee ID, service ID, the attributes company ID, service ID would form a foreign key to the table corresponding to the level company.service, because its primary key would be company ID, service ID. But if we change the name with the subtype of service ID in the table in which this attribute is part of a foreign key, for GeneXus, this doesn't delete its referential role. On the other hand, if the attribute to which we change the name, using a subtype, is the one that plays the primary key role, then in the table in which the supertype attribute appears, it does not establish the referential relation. Both of these more complex cases and the simpler ones are common in real-life applications. It's up to the developer to analyze the pros and cons of the different solutions to find the one that best suits each particular case, while keeping in mind that subtypes are a compromise solution to solve problems and should be used cautiously.